This is a question from AS2 Physics, and it was in the previous AS3 Physics paper, year 2007, and it's question 4. The frequency threshold curve for a small mammal, so this isn't a human, a small mammal is shown below. State why both the intensity and frequency scales in figure 4.1 are logarithmic. So let's just have a quick look at that. You can see there that it's slightly different from a human. Our minimum intensity that we can hear is 10 to the minus 12, whereas a mammal is way down there about 10 to the minus maybe 15 or so. Our minimum frequency that we can hear happens, the minimum intensity we can hear happens at about 2000 hertz. So the mammals here is somewhere between 100 and 1000, maybe at about 600 hertz. And you can see that this would normally go up to 10 to the minus 2 for us. So 10 to the 2 it would go up, whereas the mammal isn't hearing the louder sounds there. So state why the intensity and frequency scales are both logarithmic. And the answer is because, the same answer as always, a small mammal just like us, the range of values that the mammal's ears are sensitive to is too large to show on a linear scale. So we have to use a log scale. So both frequency and intensity and frequency values on a linear scale. So again, that's something that's asked very, very often, and it's definitely something that you should learn off. State why the intensity level scale in figure 4.1 is not logarithmic but linear. And just have a look at that. Down the right hand side there's an intensity level scale. Now the intensity level scale already takes account for the log scale, and that's why it's a linear scale. So intensity level scale already uses logs in the calculation, or takes logs of the numbers into account. State what is represented by the shaded area on figure 4.1. And just like humans, this is a range of values of intensity and frequency that the mammal can actually hear. And so this is a range of hearing of the mammal. Okay, part C. It says, contrast the hearing of the mammal with that of an adult human. In your answer, you should identify differences in frequency detection and differences in intensity detection. Quote values where possible, and there's a quality of written communication mark, so that means that you have to write in continuous prose. I'm not going to write in continuous prose, but to fit everything in. But those are the things. There's 5 marks, and they're asking you to quote values, and there's 2 things they want you to talk about. And so it'd be reasonable to assume that you maybe get 2 marks here, 2 marks here, and maybe an extra mark for quoting values. So we'll have a wee look here and think about what a human's would look like, and possibly maybe we'll just draw the human one as well. So the human one there would go from 10 to the 2. We can hear from 20 hertz, which is about there, and it's about 10 to the 2. Our minimum happens at about 2000 hertz, and it's 10 to the minus 12, which is about there. And our maximum is at about, or we can hear up to 20,000, which is there. So 20,000 would take you up to about 10 to the minus 2. So that's what a human would look like there. And so you have to comment on this. Right, and we would obviously hear everything in between there. I'll just show that in green there so you can see it. We would be hearing everything in there. Right, so it says comment then on differences in frequency detection and differences in intensity. So we'll look at the frequency first of all, and you would be commenting then that we can hear, and I'll just put this in green, we can hear from 20 hertz, whereas the mammal can only hear from about 80 there. and then we can hear up to 20,000. Whereas the mammals hearing away up to maybe 80 or 90,000 away up here. So they can hear ultrasound. So that's the first thing that you might be saying there. So number one, the frequency difference. The human hears from 20 up to 20,000. But the mammal in that diagram is hearing from, we reckon, about 80 up to maybe 90,000. So the mammal's hearing ultrasound. Also, you could say something about where the what frequency the ear is most sensitive at. So the human's ear, most sensitive at about 2,000 hertz, whereas the mammals is most sensitive. And from the scale here, if you have a wee look at that, you can see that corresponds to about here, which is about 60 hertz maybe. About 60 hertz. Oh, sorry, I'm looking at the wrong place here. Look at that again. Yeah, it's not 60 hertz there, it's 600 maybe. 600 hertz or 500. Right, number two, differences in intensity. Okay, so if we have a wee look at this again, the human can hear a range of values from 10 to the 2 down to 10 to the minus 12. So the human can hear from, I'll start at this lowest value actually, the human can hear from 10 to the minus 12 up to 10 to the 2 watts per metre squared, whereas the mammal is hearing from about 80, no sorry, 10 to the minus 7, or a wee bit more actually, about 10 to the minus 5 down to about 10 to the minus, we'll say 15 there. So 10 to the minus 15 to 10 to the minus 5. So the human's range is greater. You've got a difference there of 10 to the 14. Whereas here we've only got about 10 to the 10. So human range is greater. And really you've included nearly everything there to get you your 5 marks. And that kind of question, although it looks horrible and it's worth 5 marks, it's quite easy if you can quote values from the graph. And even on that graph, the way I did, you could have drawn the human and compared them that way.